Thanks for tuning in, guys. So we're going to be looking at this agricultural technology question paper. We're going to walk through the entire question paper from question 1 all the way up to question 6. So this is a paper that was written in 2018. Okay, so we're going to walk through the entire paper from question 1 all the way up to question 6. Now, after the cover page, you're going to have a set of instructions, right? This is not for display. It's meant to be read. Just make sure you go through your question page, your instructions for every given paper, right? They're very important, very important. Now, this question paper is divided into two sections, the section A and section B. Just make sure that you answer every question. Okay, so let's go over the first question. Question 1, section A, question 1. So for the first question, 1.1, it's a multiple choice question. Let's check out 1.2. 1.2, we are given underlined words. We need to give or make the statements true. And then the last question in question 1, we have column A and column B. We just need to match out. Okay, so let's go back to the first question, the multiple choice questions. All right, so various options are provided as possible answers to the following questions. We need to choose the letters A to D and write the correct letter next to the question numbers. Okay, so 1.1.1, the is used to remove welding spatter from metal. After welding, there's going to be some material that stays behind, that clogs up or piles up after the welding work, right? So here the is used. What is actually used to remove the spatter from the metal? We are given 4 options. Is A the answer, a prick punch? This is incorrect. Why? Because a prick punch is not used for removing material. It's only used for marking metal before the drilling process, right? But not for removing material. So we want something that is actually used for removing the spatter from the metal. What about B? A rasp, a woodworking tool for shaping wood. This one is not actually suitable for removing any material from a metal. C is the answer, an angle grinder. An angle grinder, okay? But why an angle grinder though? So welding spatter is the small material that hardened after the welding process, right? So an angle grinder with a grinding disc is actually perfect for the job, for smoothing the surface post welding. So the answer, the correct one should be C. So for 1.1.1, correct answer is C. 1.1.2, the is used to remove a bearing from an alternator shaft without damaging the components. We have 4 options in acetylene flame, B a claw hammer, C a bearing chisel, and D a bearing puller. I think this answer should be like obvious. Let me say that. It's an obvious one, this one. So D is the answer. Now, why is A, B, and C incorrect? First of all, an acetylene flame is not suitable for the job. Why? Because it could overheat and actually damage both the bearing and the shaft. So we cannot go for this one. What about B? This could also damage the bearing and the shaft through impact. So when using the claw hammer, it could cause some damages as well. So what about the bearing chisel? The bearing chisel could score and damage both components as well. So it's not a suitable tool or method for removing the bearing from an alternate. Now for the 1.1.3, the correct answer should be, you know what, let's go through this. An ideal number of teeth per 25 millimeters on a hacksaw blade used to cut 20 millimeter solid aluminum bar. All right, I'm just giving this one some thought, but you know what? Aluminium, first of all, it's a very soft material. It's very soft, especially when it comes to trying to use a hacksaw blade on it, right? Keep in mind, aluminum, it's a very soft material. It's a soft material, so we cannot use teeth that are longer or short, right? Or short. So we should find that sweet spot, somewhere in between. This is the lowest, the smallest teeth. This is the biggest. This is something closer to the biggest. So the correct answer should be B. This is somewhat ideal. Now, for the A, the 16th per 25, this is too small and would cause the hacksaw to snag and tear the soft aluminum material. Now, what about the C? I'm just trying to provide a reason as to why the A, B, and the A, C, and D cannot work in this case. So 1.2, we are, oh, 1.2 we went with D, and then 1.1.3, we are going with B. We're going with B. C, too fine and could clog quickly with aluminum shavings. That is justifying as to why C cannot be used. What about D? D is extremely fine. D is going to be extremely fine. Extremely fine. Completely unsuitable for soft materials, right? So this is out. This is out. This is also out. This is out. This is too small, right? This is too small. So we're going to go for B. 1.1.4 is used for manufacturing of O-rings. What is the correct answer here? Another obvious one. It should be B. Teflon. It is used for manufacturing what? O-rings. Fiberglass is too rigid and lacks the flexibility needed for scaling. What about C? The Persplex. What about it? Is this obvious though? You know what? I'm going with B for this one. Fiberglass, no. Okay, what about this one? Oh yeah. Persplex is a brittle material. It's very brittle, so it is unsuitable for compression sealing. So this one is also out. What about Bakelite? Hard, brittle, and thermoset plastic that cracks under compression. So this is not appropriate when manufacturing O-rings. So this one is out of the picture as well. So for the 1.1.4, we are going with B, Teflon. Teflon. 1.1.5, this material should not be grinded with a bench grinder because the material clogs the grinding wheel pores, causing the wheel to overheat. Causing it to overheat. This material should not be grinded with a bench grinder. Okay, so we have four materials. That's cast iron, mild steel, and then we also have C, copper, and stainless steel. I'm gonna go with C, copper. Okay, gonna go with C, copper. This should not be grinded with a bench. with a bench grinder. So the other materials can be ground safely with proper techniques like cast irons, mild steel, for example. It's a standard material for benching, for bench grinding. And then C, the stainless steel is also appropriate. It can be ground but requires careful control to avoid overheating. So copper is out of the picture there. It's out of the picture. All right, so 1.1.5, 1.1.5, the correct answer should be C. But you know what? For the multiple choice, I don't think I need to write anything. I can just circle the answers. Okay, so 1.1.6, the use of compressed air in the farm workshop is associated with mm, okay. 1.6, A, soldering, B, MIG welding, C, TIG welding, and then D, plasma cutting. The use of compressed air in the farm workshop. Okay. Let's eliminate the incorrect ones here. Let's start with A, soldering. Soldering. Okay, for starters, soldering does not require compressed air, so this is out. What about MIG welding? So, okay, yes, this one uses shielding gas, something like argon and a carbon dioxide mix. So, no compressed air is required for cutting with this one. So, MIG welding, you are out, buddy. What about TIG welding? Okay, so TIG welding uses inert gas shielding only, so no. Compressed air goes to D. Goes to D, plasma welding. So it makes use of compressed air in the farming workshop. All right, so 1.1.7, incorrect calibration of a diesel pump on a tractor can be identified by 1.1.6. All right, incorrect calibration of a diesel pump on a tractor can be identified. Okay, it's obvious. It's obvious. A, black smoke exiting the exhaust pipe. Noisy valve, no. White smoke exiting the exhaust pipe. Okay, black smoke, white smoke. You know what? The white smoke actually indicates something else, not incorrect calibration of a diesel pump. This, this in many cases, it indicates a coolant leak or cold start issues, but definitely not a calibration issue. So we are taking this one out as well. What about the engine that backfires? Okay, no, this is related to ignition timing, but not fuel pump calibration. So the correct answer should be A in this case. 1.1.8, modern technological systems such as are used to notify the operator when grain is blocking the system in the combine harvester. Okay, interesting question. Interesting question. Um, okay, modern technological systems such as used to notify the operator when grain is blocking the system in a combine. Okay, you know what? For this one, I'm thinking I'm gonna go with B. All right, let me reason against the remaining options. A, yield monitors. These usually measure harvest quantity but do not detect blockages. So that is why I refrain from choosing A. What about C? Neuron probes. Neuron probes measure soil moisture content. They don't tell us about any blockages. So this one is out of the picture as well. D. Tensiometers measures soil tension for irrigation. So this one is out. So flow sensors, yes. is the correct one. 1.1.9, the drain pipe connecting the toilet to to the septic tank is made from obvious one. It's obvious. It's obvious. PVC pipes. PVC PVC pipes. We are normally using PVC pipes for connecting the toilet to the septic tank. Okay. First of all, it's not like you we cannot use copper. Copper is it's actually material that can be used for connecting the toilet with the tank. But the problem is copper is very expensive and it can be you know it can be subject to to theft, right? So we should avoid. And another thing is that it's actually prone to corrosion from waste chemicals. So definitely not copper. What about latex? This thing is not rigid, so we cannot use this thing. So definitely C should be the answer in this case. Iron, definitely not. Okay, the last multiple choice question. The most suitable all-purpose fire extinguisher for a welding workshop. Okay, another obvious one here. So the correct answer should be the dry powder extinguisher. These ones are not appropriate for putting out welding fires. So the dry one, it's the best option. It's the best option. Now, 1.2, the next part of our question 1. They want us to change the underlined words in each of the following statements to make the statements true. Write only the words next to the question numbers. Okay, so we have a case here. 1.2.1. All right. Okay. So safety signs attached to an electric fence must be made of plastic with a red background. Okay, so let's answer the first one. Safety signs attached to an electric fence must be made of plastic with a red background. Okay, now let's think for a minute here. Red background. Red background. So we need to change the underlined words to the correct one. I'm going to say yellow for this one. Now, the question is why? Why? You know what? The red background is incorrect because international safety standards specify yellow for electrical hazard warnings like high visibility and for universal recognition. Now, metal signs are, you know, I'm not sure about the plastic, but you know what? Let's just focus on the underlying words. I think instead of saying plastic, they should have said metal in this case, but that's fine. That's fine. That's fine. Let's not argue with the examiner on this one. Let's just roll with the question. Now, I'm saying yellow um, because of standards. Not red, but it should be yellow. Now the 1.2.2, a newspaper is the most effective type of communication to inform farm neighbors about an immediate emergency. Okay, this is going to take some time because you need to send out the information to the publisher. Then the publisher will have to write down an article or a story or something like that. And then they'll have to print the newspaper and go and publish. So this is going to take a while, right? It's going to take a while. So definitely not a newspaper. Okay, not a newspaper. So it can be something like maybe a radio, um, even a siren, can also be um, an effective method of communication. I'm also thinking maybe even a cell phone, WhatsApp groups, something like that. that could also work. Now, newspaper is definitely not an option. It's an emergency situation. So the message should get as quickly as possible to the neighborhood. To 1.2.3, a one-way valve is a device that is capable of adjusting the water delivering time in response to current environmental conditions. A one-way valve. A one-way valve. Okay, okay, okay. All right. Um, for this one, I'm thinking a smart controller would do us some good. Smart controller. A smart controller will do a better job in this one. Okay, so so a smart controller, I think it's going to be a device that is more capable of adjusting the water delivering time in response to the current environmental conditions, right? So you know what? Oh, thinking about it, I think a one-way valve, it's this one, it only allows for flow in one direction, so it cannot adjust timing or respond to conditions in an effective way. So I think a smart controller is going to do a better job. So the answer for 1.2.3 should be a smart controller. So 1.2.4, compressed air is used as a hydraulic fuel in a car's bottle jack. Is it? Is it? Is it? No, no, no. It should be oil, a hydraulic oil, hydraulic oil. Even if you wrote oil, I think it's gonna work, but hydraulic oil for a more descriptive answer, it should be a hydraulic oil. Um, well, it should be oil because since oil is standard in all hydraulic jacks and equipment in cars. Now for the last one, 1.2.5. Steel that has a copper coating produces poisonous gases when subjected to welding. Copper. So we need to change this underlined word to the correct one. So no, no, it shouldn't be copper. Shouldn't be copper. Well, copper shouldn't be correct. Shouldn't be correct. Copper, you know what? Copper coated steel exists, but you, sometimes it's for conductivity or corrosion resistance purposes. Yes, but copper fumes are hazardous, but not typically described as poisonous gases in the welding context. So I would say not the most common coated steel in agricultural settings, right? So I'm thinking zinc coating. Zinc coating is the appropriate one. I think it should be the correct one. It's very common in farming applications. So we should go with zinc for this one. We should go with zinc for this one. Let's go with zinc. Now for the 1.3, the column, the matching. Matching. It's time for matching now. We have to choose a word or term from column B that matches the description in column A. We need to write only the letter A to H next to the question numbers. Okay. All right. All right. All right. All right. All right. All right. Now 1.1.1.3.1. Alloy elements used in the manufacturing of stainless steel. I wonder if you guys are doing physical sciences. In grade 10, yeah, grade 10, alloys was a big discussion in physical sciences. The blending or the mixing of metals to obtain a new metal. All right, so for the 1.3.1, alloy elements used in the manufacturing of stainless steel. Stainless steel, if you know your metals or if you know stainless steel it's somewhat a tough piece of metal, and it's also somewhat resistant to corrosion to some extent, of course, right? So we have F as a possible solution or as a possible answer for the first question, and D as another option. So these are two metals that are combined to give us an alloy, right? An alloy, but one of the two should be correct. So the answer here is going to be D. I'll explain why. I'll explain why. 1.3.1. The answer is D. It's definitely chromium. Chromium, it provides you know, the chromium oxide layer that actually prevents rust, right? So it provides the corrosion resistance element of the stainless steel. And then nickel on the other side, it's one tough, okay, it's one tough material or one tough metal. So it adds the toughness or the ductility and enhances also the corrosion resistance, right? Now, for the next question, 1.3.2. You know, I feel like I'm not only answering the questions, I'm somewhat giving a bit of a lesson on the side. So just let me know in the comment section if you do appreciate that approach, or should I just go straight to answering the questions? Anyway, 1.3.2, a heat resistant plastic. So these out of the picture. So let me stretch this out. So we have porosity, argon cracking, acetylene, backlight, and perspex. Okay. Okay. Answer should be G. A heat resistant plastic. A heat resistant plastic. So I don't know if you know this, but backlight is the first synthetic plastic and also has excellent heat resistant properties. You know, this is one thermosetting plastic that doesn't actually melt when heated. So it does it does melt, but to a certain temperature, at a certain temperature, at a particular value of temperature. It can actually withstand temperatures to up to 200 degrees Celsius. I'm not sure. Let me just check quickly. Yeah, yeah, yes, yes, yes. Around that range, between 150 and 200 degrees Celsius. And it's also used in electrical insulators. That explains the heat resistance of this plastic. So the answer should be G. 1.3.3, the MIG welding defect that occurs when the gap between the nozzle and the workpiece is excessive. When it's excessive, okay, the answer should be A, porosity. Out. What else is out? G is also out. Now, how can I justify this? Okay, porosity actually refers to gas pockets or voids in the welding bit. Yes? Now, when the nozzle when the nozzle to work distance is too great, shielding gas coverage becomes inadequate, right? So I think, you know what? This is the appropriate one. This is the appropriate one. This is the appropriate one. Make detects, yes, yes, A, definitely, definitely. Then 1.3.4, the gas with the highest cutting, the gas with the highest cutting capacity used for plasma cutting. Argon is a gas. This is not a gas. That is not a guess. That is not a guess. E is also a guess. Okay, it's also a guess. So we have two options, B and E. B and E. So between the two, which one is the correct one? I would argue that E is actually the correct answer here, right? Okay, while plasma cutting primarily uses compressed air, argon, or nitrogen, but the question actually tests the knowledge of thermal cutting capacity, right? So the acetylene has the hottest flame temperature of, you know, about 3,000 or so of cutting fuel gases. So acetylene cutting, this is the high temperature. Now, this high temperature actually allows the rapid pressing and cutting of for plasma cutting. So the answer should be E. 1.3.5 last question. A highly flammable gas that is commonly used in the workshop. That is commonly used in the workshop. Um, let's see. Argon is an option. Argon is definitely an option. Uh, it's a guess. It's a guess. And then acetylene is also an option. I would also say that E is a highly flammable gas. Yeah, acetylene. A highly flammable gas that is commonly used in the workshop. It's definitely gonna be the acetylene. This is the primary fuel gas in oxy-fuel welding and cutting. So it's a common gas that is used in these types of um, in workshops. In workshops. So E is gonna be our answer for this one. Now, section A, 40 marks. Now we are going for section